Thank you, Nash. Well done. Well, thank you. Thank you so much. Thanks, all. Good to be here. Hi, I'm Mark. I'm a sociologist. Good to be at Northwestern. It's my first time here. Nice place you've got. Uh, yes, that all those lovely leaves are going to be gone soon. So let's see. I care a lot collective action, how the shapes the ability of groups of people to get things done. Been really fascinated by the net decades, too long. Um, Back when we used to take 2 cans and a string. But I was reminiscing about the word baud. Nobody says the word baud anymore. Baud mode. In any case, for the last 15, 20 years, I've been building tools social media, back before we called it social media. It used to be called virtual community, online community, groupware, social computing. Before that, it was executive decision support, the decision support when the executives left. So collaboration, what was it? Computer-supported collaborative work, CSCW. So it has come and gone under many, many names for many, many years, but it's essentially what happens when two computer that in some ways mediates. And the interesting thing I find is that the mediation is not a transparent conduit. It's not that nothing changes. Call somebody or text them or mail them or blog and get a reply. Something does change. Something changes in the costs and benefits of. It is possible, for example, to aggregate much larger populations through computational networks than it is in physical spaces. It is a non-trivial event to get this many people into this room. It takes a lot of effort. You all had to be within driving distance this morning for this event. But we could all be listening in to a call or a webinar or something, and it could be from any planet, and it is therefore possible for N to be large, the population. When N is large, even the unlikely is likely, because now the unlikely thing, somebody's going to do you a favor, somebody's going to generate resources for you and give them away. That's unlikely. But when N is large, it's almost a certainty that. So something interesting happens when human societies move into. The way I find it useful to understand that is to actually go out and. The challenge I have, and maybe too, is that I'm a social scientist, not. So, quick show of hands, how many of you code? So, about a third. About a third. And for the rest of you, should we simply deny you access to the benefits of these insights? No. And so I have a few things I want to tell you about today, and one of which is I share your disability and I admire your abilities. For the non-coder, there is now a tool, social media analysis. That tool is this tool we call NodeX, Network Overview, Discovery, and Exploration. And it is free and open, available on the web right this second. So you can take it and plug it into your copy of Office 2007 or 2010. It doesn't run on your Mac. I have a special. It does run, but you have to go to Amazon. And using this tool, you can now actually draw pictures of collections of connections. It turns out the web is all about creating networks. It is a network on which many networks. And for the most part, we are living in a phase in which we are still building authoring tools, ways of authoring links. Entities are diverse. There are people, or at least user accounts. There are documents and all sorts of other digital objects. There are emails, there are videos, there's like. And there are a range of connective tissues that link them. Indeed, there's the link, the like, the favorite, the rating, the review, the reply, the comment, the edit, the read. All of those are tied ways of associating one thing with another thing. And when you aggregate these collections of connections, you get a structure. And that structure actually tells a story. And until recently, that story was a difficult story. It was hard to get the collection of connections. It was hard to run it through the various techniques unless you were a coder. And so we've had the physicists in the doing great work, but noted that the computer scientists in the almost never took Soc 101. And the Soc 101 people rarely took the fundamentals. So we need to build a bridge. So about me, let's see. I spend a lot of my time in social media. All of these are, of course, repositories of connections, and you can find a lot about our work, both research papers and publicly at one or more of these. So first, I'll note that human beings tend to aggregate, they congregate, form crowds. In the old days, you would look out at a crowd and you could actually learn a great deal about the crowd. You could tell something about the composition of. Is it an angry crowd? Does it come in clusters? People under that sign are different from the people under that sign. They indicated some way of how they formed up as sub-communities in a physical space. Today, we still aggregate in crowds in physical spaces, but more and something is lost in. Not that it's completely lost, it's just latent in the transition. It is something that I think can be explicit, that can be surfaced. So, for example, you do have hundreds of thousands of people, they gather, they want to listen to a politician, and yet when they talk about that politician in Twitter, all of the connective tissue is and so that most recent tweet, well, that's just that. That's the most recent tweet. Is it the most important tweet? Is that the most important author? Of course, we could now have a discussion about what did you mean by important, but let's hold that aside for a moment. This does not give you any of the social connective context. You don't know the graph. Well, now you do. That's the Obama graph for a little bit ago, and it's something that allows us to go to Excel, type in, go to the NodeX menu, go to the data import menu, go from Twitter, type in Obama. This is a collection of people who mentioned Obama and how they're connected to each other. There are several things to observe. These are people who are called isolates. They don't connect to anybody else, or at least they were not observed to be connected to anybody else who also said the word Obama. What would it take to be connected? So we actually mine out three kinds of things. There's the I followed you. There's I mentioned you by name, and I replied to you by name. So if I say at your name, something, 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 that is a reply. If I said, I was just having lunch with at your name, mention, if I simply follow you, each of these edges could be any of those, and using the tool, you can actually label them, you can color them, you can give them edge thickness. In this case, the nodes are Twitter profiles. The size of the profile photo has been scaled to the number of followers. And it's worth noting that the number of followers is always equal, and that it is possible to have a very high or other forms of centrality and not have the max number of followers in the graph, because your followers may not be on the graph. You may be what I call a visiting dignitary. You're somebody who's really important. You've got a lot of followers, but when you step into this ring, it turns out you're not that important. And so these kinds of graphs really tell some interesting stories. Who's at the center? Who's at the periphery? How dense is the graph? Who occupies key positions like that of the bridge, the only who links two otherwise separate clusters? So people have been building these technical networks, and on top of these technical networks, several social networks evolved. And the question is, how can we actually do them? So, of course, you'll want network theory. I suspect you're all pretty familiar. So I won't go into this all that much. But network theory turns out to be a very potent language. These collections of connections. And we all know the key concept of social network theory, and essentially a variation on the concept of real estate. Three most important things in real estate, and they are, of course, location, location, location. In network theory, it's a little different. It's position, position, position. So we can now look at who's at the center of the graph, who is the bridge to some other sub, who is isolated. And over here, you're seeing the network, the subgraph image. This is each person and their network around them. You can see some people are highly connected to a lot of people, but those people are not connected to each other, versus some people are in close cliques with, of course, the number is the clustering coefficient, people with high clustering coefficients. So the key thing to observe about the web is that there are many kinds of ties. And you can link and like, favorite and share, follow and friend, edit and read. There are more, probably. Not all of these ties are born equal. They're not all of equal importance. But some of these ties really matter. And my invitation, of course, is to think link, that you need to be thinking like a collection of connections, and that you can get this vocabulary of in and out degree, and there are lots of ways for things related to one another, and there are ties of different types. So to relations. And there are, of course, nodes of different types. So on. The collections of connections can be calculated. We can actually start looking at central by the 4 or 5 different major centrality scores, and this starts to tell us about importance in the graph. And there are many kinds of graphs out there, and building tools that essentially pave between you and the graph sitting in one or more. In fact, you could argue that the definition of social media is something that creates a graph. If you cannot join 2 user IDs or 2 GUIDs to one another, there's a good chance that you don't have a social media. It is defined by its connective properties. So we have been building a tool, and this tool allows you to do essentially the 80% of network analysis using a GUI that can be automated and allows you to basically get your centrality scores, get your degree measures, figure out your clustering coefficient, a variety of things, and even draw the graph and map various display attributes to the data attributes in the graph. And all of that without a single line of code. So for those of you who are thinking, steady code, why would I want to have 0 lines of code? We respectively say, of course, yes, you may not really be looking for this tool. On the other hand, even the coders in the room results to others who may in fact want to manipulate the graph delivered. And so think of us as Firefox. We are the free and open platform that renders a data structure. It's not HTML, it's GraphML in this case. And so we're a GraphML browser. We do, in fact, read and write GraphML. We also do use INET, CSV. So you probably already, I don't need to explain why Heather is. You know this, right? Yes. All right. So I wanted to ask you if I could use this slide, and I figured the best way to do it is just take, I love this picture. And so can I use the slide? Can you email it to me? I will. Okay, thank you. So I was just in Sacramento. I've got more. So, this has a history. It's about 85 or so years old now. Jacob Moreno, back in the day, he started building these diagrams. They were originally called psychological geography. That didn't work. He changed the name. Sociometry. That had a little bit more success until Dr. Moreno began to claim that he was in communication with the Almighty. For whatever reason, that drives away graduate students. I don't know what it is. I mean, I think many graduate students already think their professor is God, but in this case, when your professor is actually saying that you are in connection with the Almighty, it's a troubling thing. But these are the first hand-drawn are people on the call team and the affinity and disaffinity of others, and already the language of network concern, and things have gotten better, right? We've gone through a transition in which, for one thing, we don't actually draw them by hand anymore. And the data that we collect is no longer considered a large data set if you have nodes. There are maybe 14 nodes on this. We're now living in a land and a world of abundance. Used to be sociologists who were data poor, and we have an embarrassment of riches. The question is, social scientists really chew on terabytes and petabytes and squeeze from that sociological insight. And can they do it without the computer scientists? And probably not. So we really need to build that bridge. Those parts of the social science community and those parts of the computational science community that will lead to these kinds of insights. And certainly at the meso and, the meso and the macro scale. So I'm going to move past that. You guys don't need this. So some neat features that we've been able to implement. This is that we went to Excel. We Flickr, give me all the tags. Tag mouse. This one illustrates a really nice clustering quality of steps. The blue cluster, that's mouse as rodent. You get associations like cat, tail, dog, sorry. The upper orange one, that is mouse, the pointing device associated with words like computer, keyboard. And then the other cluster, that's the red cluster, we call that the Mr. Mouse. The Disney Corporation, Burbank, Mr. Mouse. Fun that town. So this really illustrates nicely, and with another click, you can turn them into illustrative photos from Flickr to really highlight, hey, there are 3 different meanings of the word mouse that are in widespread use. Here they are. And find clusters in networks. So we've been doing some research where we find not only are there clusters in networks, but there are structures in networks. Structures vary. In particular, there are various kinds of video networks. These are images, message boards, or discussion groups. And this is a very common. This is the I replied to graph. And I guess my question is, have any of you ever had a question and asked the internet a question? Anybody get a good answer? Something, yes, I married that person, that kind of thing. Did the person who answered that question know you? Probably not. Did you ever plan to do them a favor in return? Probably not. How is this possible? From a sociological perspective, why do strangers you'll never meet, who don't know you, will never benefit from anything you will do for them, help you? And it's a good question. And the answer is probably the obsessive compulsive. The other answer is it's not all that common. So you may ask questions. In fact, it is common to ask a question. How common is it for a question? So let's try that again. How many of you ever answered somebody's question? Very public-minded. So this answering thing, though, turns out to be less than half of a percent of the population of any city are answer people, the people who answer other people. And they leave a trail behind. They leave a distinctive trail behind. They have a network motif, which I will simply summarize as high out degree, low in degree, low clustering code. They are stars, right? They are the people who, somebody walked into a room and said, I can't print. They stood up and said, you need a new print driver, here's the URL. That person left the room, and it turns out, in almost every case, does not even bother to say, thank you. Polite place. Which is good for me, because otherwise there'd be in degree. That would ruin my model. So stay in polite. I appreciate that. So this is the pattern of an expert. This is the pattern of the answer person. This is that guy who mostly points outward to people who themselves have very few connections to each other. These are some exceptions. But statistically, these are people with very low clustering coefficients, high out degree, low in degree. And they're completely different from the other two kind of people. And again, these two kinds of people play other role positions within the community. They're critical, but they may not appear in the same community. So the answer person and the discussion person are often not in the same space because you don't go to the same environment to ask and answer a question as you do to argue about something. This is discussion person. High in degree, high out degree, high clustering coefficient, high. More than one message passes over the link between links. That's the discussion person. It's language invariant. It has no NLP as part of its method. It is only structure. It works. And we've got a few papers out there where people, well, how do you know it works? Well, we use the best semantic analysis. A group of 8 graduates who read several 100,000 messages for us, well, 15,000. And they rated them on all the dimensions. And then we correlated that with these attributes. And question people generate questions. Question people are, of course, these people. How do we know a question person? It's the person who got an answer from it. And discussion people are different as well. They're, in many ways, the inverse of the answer person. They're high in degree, low out degree. So it turns out that the discussion starter does not typically participate in their own conversation. These are the people who walk into a message board and say, did you see that article in the New York Times? And then 25 people jump on it and start talking about it. The people who talk about it are different from the people who start it. Some people start the fire, some people. This is discussion. So these maps, these ego nets, let us start to say, wow, people are not all the same. They come in flavors. The really important flavors are really trace elements. They're like vitamins. You don't have a sit down to a steak full of vitamins. Trace elements, a little iron, right? They leaven the whole. If it were not for answer person, half the population, 99.5% of the population of question people would be clueless. And so the answer person is a really critical person, and you will know them by their trace. You will know them by the pattern of connections they leave. So it's now possible to extract these and say, oh, well, any bucket of content is characterized by essentially the gas chromatograph analysis of that bucket of content. You can say, well, how many answer people have you got? How many question people? How many discussion people? Well, you don't have many discussion people. You have a few answer people and a lot of these question people. I bet you're a Q&A. Oh, you've got a lot of these discussion people, not too many answer people. You must be a discussion. So you can now characterize the nature of the social without actually looking at the network. We found some interesting findings. We looked at political discussions, and a couple of years back looked at news that had the word politics in their name, characterized each author based on people found connections to people with the same orientation or the opposing orientation. And in this case, we found that people reached across the aisle to people of opposing viewpoints. We thought that was really exciting until we did it. Because what do they reach across the aisle to do? To punch the nose on the face of the person on the other side of the aisle. So this is kind of interesting. You might say, wow, segregation's a bad thing. We don't really want that. We want people to actually interact. Well, it turns out when they interact, so with their fists, verbally, but if they were in the same room, they probably wouldn't have done this. So we've now been building this tool, NodeX, to make these kinds of findings easier to do. All of that work using the typical method of our developer is here. The developer will get us to the data and do all these things for us. What happens when you don't? So you get this tool, you download it, you get a menu. All the different pieces of a graph, so on. And we've been producing this for a little while now. So long that we now need to put some framework around it. Founded the social media foundation, which I guess uncharitably could be called the Keep NodeX Alive group. And more charitably, we have declared ourselves committed to the mission, open tools, open data, open scholarship. Think of us as the Firefox of. And so we have attracted a remarkable cadre of people. They're not all even on this slide. We seek all sorts of people so long as we don't have to. We have attracted folks from Stanford. There's Yuri Leskovich. Oxford, there's Bernie Hogan. Of course, Ben Schneiderman from the University of Maryland. Marta Mendes Porto. Vladimir Barish, who is the student of John Kleinberg from Cornell. And hey, like Natasha Frayling. These folks get together now every Wednesday morning, Pacific time, I guess, time. We've been meeting on every week for 3.5 years. And for those 3.5 years, we sit around and bicker over what's the next feature. What are we going to add to really meet our aspiration for it, that it becomes the main method for dealing with graphs for the non-algorithm. If you are a coder, Python's great, Java's great, iGraph is wonderful, RSNA is useful. There are lots of tools. And if you're not, there's us. So we wrote a book. Derek Hansen from the University, graduate of, student of Paul Resnick, and of course Ben Schneiderman, myself. We wrote this book. The book's here. Consider the book a cookbook. You probably would skip the first half. That's the introduction to social media, the introduction. But the second half of the book would probably be interesting. And that part of the book is essentially what we call the silo chapters. We have a chapter on graphs and Twitter, Facebook, one for wikis, blogs, chapter on Flickr, another one on email, and I think I'm missing. So each of them is the how-to guide. It's not really all that theoretical. It's let's go get the graph, do these steps to it, and look, you'll find something. Maybe you should do it for your own graph. Maybe you'll find something. So that's our menu ribbon. And just to give you a little tour of just how easy it is, imagine you're sitting in front of a screen. There are two columns. There's vertex 2. We're going to type. And let's pretend that this graph of who invited who to a party. So we simply type in the name of the inviter and invitee, and you say show the graph. Get a graph. That easy. We could then lay it out a little bit more differently. We could start to make this a little bit more sophisticated by saying, well, actually, invitations don't go both ways. Invitations are directed. I can't invite you and you invite me to my party. That doesn't make sense. So these are directed edges. So we'll put arrows on them for you. You just go directed or what type of graph is it. And you can then select an edge and it'll light up in the. And we can even then lay them out in a hierarchical manner, or we can begin to decorate the nodes and decorated. Now, I know there are many other software packages out there for analysis, and one of the things I do is listen to the email list for all of them. Recurring themes. How do I change the color of a node? You'd think that would be like, how do I change the font? And it ought to be easy. So we make it easy. How do you do it? You go to the color column for your row. You type in the name of the you like. We recognize most color names. Want it to be red, type red. That's how you do it. So our goal really is not, do we have the latest P-star or ergom model? Our goal is, do you have a graph? Do you want to do the basic things on it? You can do the basic things. Now, does that mean that we never want to do ergom models and P-star and that kind of stuff? No, we want to get there, but we're not there yet. And I think that there's the good 80% chunk of the user tasks that are out there need to be done, that can now be done. So vertices have a bunch of visual properties. They've got a color, they've got a shape, they've got a size. file that you would replace the shape. We do a bunch of primary, all the colors, have opacity, that's how transparent you are, and then the magic visibility column, very important column. The thing about NodeXL is Excel, right? Excel is a reasonably powerful platform. I mean, it's not SPSS, but it's a reasonably powerful data analysis. And it has this lovely feature, formula. So imagine the visibility column for a minute. Visibility governs, do we show your edge? Do we show your node? Now you could add all sorts of other properties to the graph. As a fact, we have a column heading called add your columns here. You can insert as many columns as you want, and maybe you have height, maybe you have blood pressure, zip code. You can have any attribute of a node or an edge. You can go to the visibility cell for that node or edge, and you can type in something as simple as sign if paren, if this node has a value greater than that, then show me, otherwise don't. And so it becomes remarkably easy to filter the graph just by typing in a few if statements. I'll note that that seems too hard for our users. And so we have another feature in which you don't have to do that at all. There's a thing called dynamic filters, and you simply grab the slider and you for you as well. But there are things that are dynamic filters, which tend to be just a linear scale, and you've got a start and an end. You might want to have something that, if it's less than 5, don't show it. But if it's more than 25, don't show it. That would be harder for us to do. So there are many things that NodeXL does do. That's great. There are many things that it does not do. But you could do. You could do just by using formula or Excel. Of course, then there's all of VBA, application programming language. But that would violate one of our key project, which is how many lines of code do we want our users to use to get their work done? Target number of lines of code, 0. Absolutely none. That's the goal. Now, what if you do code? Wonderful. We're delighted. And we are a completely open C#.NET STO. And there are lots of developers who are saying, hey, why would I build the WPF canvas to draw nodes? Why would I build the metrics calculator? It's already there. And if you are a coder, wonderful. If you're not, there is the application. There was this breakout bestseller. I'll just go past that. These are some of our spigots. We call spigots anything that is a data provider tells you, you basically go to this menu and you can pull in a graph from any of these sources. The first block of basically other network, read your PIAC, read your UCI. If you happen to have CSV, you might have opened it up in a spreadsheet. You might have an edge list in a spreadsheet. Fine. Open up one of our templates and then point at the Open Edge workbook. We'll bring it right in. I showed this to Nash. So he said, yes, but where are my matrices? Matrices. And one of my messages is certainly, tell me what we don't have that we really want to know. It's not a guarantee you'll get it, but there's a chance. And if we don't know, there's certainly not a chance. So let us know what you need. For us, the interesting thing has been to go out and get graphs from a range of very prominent data sources. Who has email? If you have your email on a Windows machine, and even if you don't, you could get it to a Windows machine. Download it. Windows now, by default, has desktop index. Come back in an hour, and your mail's been indexed. Go to the From Email Network tab. It will give you this dialog box. You know, what dates? Should it have an attachment? Do you have to be on the for the two? You can set all of these things, and then you will have a reply graph, a graph of who replies to who. You may think, well, I know who replies to who. And it also shows very interesting things, like who are the clusters of people I talk to who also talk to each other, at least as seen within the event horizon of my mail. Because if I talk to A and I talk to B, but A and B talk to each other outside of my view. I don't see that edge, but you can actually see some very interesting things in your mailbox. The other thing to consider is how much of your mailbox is actually filled up with where you are not the ego mailing list. You are the but a lot of what's coming into the inbox is actually this set of discussions from the mailing list, in which case you get a full directed graph without being sort of. The other data, Twitter is very popular. Twitter, if only because it is itself very popular, but it's also very open, wide ranging in terms of the topics the melodies that it tracks. The World Wide Web is also a graph, a hyperlink graph. This is, I think, a really good example of some of the maturity of the product. We did not and do not have a hyperlink graph data provider. But a colleague of ours, Professor Robert Ackland from Australian National Australia, Dr. Ackland, many years called VOZON, Virtual Observatory for the Study of Online Networks, unlike Sonic. And it was a command line tool. It ran on Linux. It was, I started talking to Robert, and he's like, "It's so ironic that I can actually tolerate you, because you're a Microsoft guy." And right, he was one of those rabid, anybody but Microsoft kind of things, and he's found it ironic that we have now delivered him thousands of users who could not really make good use of his tool because he didn't have the interface. We had the interface. We did not have the back end. Together, to get something very. So we seek spigots. We would like to build spigots. A lot of conversations in the last few days. Data sources like the Edgar database. Really, Edgar contains board of directors and other corporation. Other data sets that could be interesting. SharePoint. For those of you who are thinking enterprise computing, SharePoint's an interesting. Almost all of the Fortune 500 runs on SharePoint. So there are things like I uploaded the slide deck that you downloaded graph. That's an interesting graph. The other interesting thing about life inside the firewall is the presence of directories. DAP server. This tells us about the nodes graph. Like, what building do you sit in? What's your job title? How long have you been in that job? Who's your manager? Which cost center are you in? And suddenly you can draw graphs of corporations that don't show people sending buildings sending mail to buildings, or job titles sending mail to job titles. Lightning. For example, we found several groups in a large corporation, all with the name marketing in their title, with no connection to each other. You kind of think, well, wait a second, do you guys know each other exist even? And so maybe you should connect. So we also do YouTube, and we have a chat. That was the one I forgot. Of course, there is a user network and a video network. And in the book, there's a great chapter on YouTube video networks from Jen Goldbeck and Maryland. They studied things like healthcare. Healthcare was the hot topic of the time. And you could find some very interesting patterns in terms of which were the most central videos and what were the critical valence of that. So all of these spigots bring data to you. The tool then allows you to analyze them. We like to think of this as dissertation box. Just add insight. Graduate student, mix, wait 3 years. There's a lovely demo of our tool narrated by Eduardo, professor of computer science. If you go to YouTube and you type in video, very interesting data set. We got this from the folks at Slate Magazine. They did the very hard work of congressional record for the year 2007, and they built a data set of every senator and how that senator voted of their agreement with any other senator. So you've got, what is that, 1,000? So you've got all of these edges of, how much did McCain and Obama, while they were still senators, How much did they agree? And interestingly, the average amount of agreement is 35%. You wouldn't have thought it. But really, these are agreements on things that are just not crucial, like resolve, kittens, cute. Yes, 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 you've got my vote for that, Senator. But when you take the little dynamic filter slider and you move it up, move it up, move it up, there's a point where suddenly two clusters emerge. Coast and west coast. Right wing and left wing. And so you get this tight cluster. There's McCain. There's Obama. And then there's the between people. And people sometimes ask me, is it good to be between? Well, depends, doesn't it? Sometimes when you're between, you have arrows in the back from both sides. And who were the most between people in 2007? That was Spector, Snow, and Collins. How'd that work out for Mr. Spector? Not so good. And I'll show you some work from Scott Golder and Vladimir Barish, both from Cornell, where on the day of the election, I think it was, they built the Twitter graph for Spector and for Sestak. They look different for us to now believe that we can predict all elections with no, based on the density of your graph. That may be an overreach, but I think there is something interesting said. And I've been generating now the graphs for every day. I generate the Meg Whitman, Barry Brown. Here, but Barry was the governor of California. Would like to be the governor again. Was the governor of eBay. Would like to now be the governor of California. I'm not that delighted. So this gives us some interesting insights into the nature of social relationships, even when they're not email and Flickr and YouTube. There's a graph everywhere, and how we can surface it and understand it. So you may be familiar with an image called "Divided They Blog" by Lot. And her graph showed a content classified map. Blogs, they were colored. And what they showed were two very, very distinct clusters. Red people and this is an image that I've entitled "Divided They Tweet." And this was made with NodeXL on the 5th of September. And NodeXL now has a feature called the NodeXL Desktop Server, being available. And using it, the equivalent of a cron job schedule. Cron job, you actually go to a part of Windows called Task Schedule. And you use Task Scheduler to say, let there be a Twitter query at 1:15 a.m. every day, and let it be for the word GOP, or fill in the blank word. So I've been building this graph every day for months too. And in fact, one of our asks is, if anybody's interested in this, one of our offers is, we've got a lot of data and we're happy to share. I have literally 6,000 to 7,000 graphs now, daily snapshots of about 120. I do the daily oil spill graph, the daily BP graph. Actually, I do BP by the hour. I have literally hundreds and hundreds of BP. Oil spill, BP, global warming, climate change. A lot of different keywords. And I can't say that there's much rhyme or reason to it. It's just sort of like Marc thought of, hey, let's do that. So, iPhone, Android, yes. So we're doing all of those. And so it's now possible to schedule your own data collection. And we have a lot of data we want to share. In fact, if you go Googling around, it's up on the web now. Put up hundreds and hundreds of. Further, if you were running one of these things and you were so inclined, we'll take your data and make it available to other people. Open data part. What we envision is a giant distributed denial of service attack against Twitter. Not our intent. If only they would give us the fire hose. What we really want to see is 100 data collectors running around the planet. Each of those installations collecting data that's relevant to the researcher behind that server, but then aggregating the results into an archive that our efforts curate. We will then stuff it into 3 or more repositories. We are thinking that Fusion, Amazon S3 Scientific Data Archive, and Internet Archive, 3 leading places we will go and take all of our data and upload it, make it publicly available. So if you are interested in running, do let me know. So we are now collecting this data, and we are in a position to start, well, we tend to build features that then cause trouble, that we then have to build features to mitigate. And so first we built the data collector, and I ended up with literally thousands of graphs. And those graphs started to languish. Click, the 52 clicks that it takes to take a graph from raw to cooked. And so we automated that. We now have an automation feature in NodeX. And this one back here is, you're not NodeX. So this is the Nico graph. Live, have no idea what's going to happen. You can now go and do a completely automated process. This is NodeX. There it is. There are some edges. This is the vertices. These are every vertex. We will now do save the Nico graph. And this is how we process a graph in NodeX. This is the automation dialog. It offers you pretty much the name of every single feature that we offer. And I have pre-configured all of these. I said, yes, I want all the metrics. Yes, I want you to cluster my graph. Yes, I want you to do all these things, including even saving an image of the file. And then I drink coffee. And my right arm hurts just watching this, because the carpal tunnel's really getting bad. So this saved me from worse carpal tunnel. And so it's chewing around, it's doing this, and I want to point out, I'm running a Mac, and your shows on the screen if I do that. Amazon EC2 is a remarkable service. Rent you a virtual Windows machine, and all you have to do is go to aws.amazon web service. And I believe there are others, but I've been using great success. You can then dial up as big or as small a Windows machine. You can Linux machine, you can Virus machine, you can all sorts of machines, virtual machines. And you can pay for this machine by milliseconds. When you have enough milliseconds, an hour, you owe Amazon hour. So that means that you can have a Windows machine on your desktop, a Mac desktop, you can have a Windows machine virtually for the cost of 72 cents a day. It could be less if you turn it off at night. That's about $270 a year. And that's if you don't turn it off. And so here we have just calculated the clustering. We've clustered everything, and let's go take a look at the graph. Now let's take a look. We have this nice feature where we'll move all of your isolates to the bottom of the graph. There we go. And that is the Nico graph. We did that with not too much pain. This is this one maybe. This is the Northwestern graph. There you go. So these are people who tweeted the word Northwestern recently. That's, of course, the Northwestern Twitter account. It's really big, and it attracts all these people. So the question is there a community in Twitter that says the word Northwestern? The answer is not so much. So, and how do you know? Well, largely because there's no clustering coefficient around the graph. So, Oh yeah, I'm just going to do this one real quick. So this is the global warming graph. This, say the word global warming. Stop saying that. All the people who say global warming are deniers. I think it's too charitable to call them skeptics. This is an illustrative tweet. When the next ice age begins, the tofu eaters will still be talking about global warming. Sir. Up there, I refer to this cluster as the did not receive memo cluster. So these are people who are still talking about the scientific discourse and the evidence for various forms of anthropogenic climate change, but they're saying global warming, and they just don't realize that we're just not going to say that anymore. What are we going to say? We're going to say climate change. And climate change really only has the one dominant cluster, and it's worth noting that the Fox account is just not very central in it. And it's dominated by mainstream, fairly prestigious forms. So this has also been applied to Facebook. That's a Facebook graph from Bernie Hogan's tool. Now we read GraphML. There's Scott and Vlad, and they did the SESTAC versus Spectre graph, and there's the SESTAC versus Spectre graph layout. And the main observation is more clusters, denser clusters, led to no doubt Twitter was the defining factor in that. So what we've started to do is move from looking at social media like this to a world of badges. Thank you, Crowley. We tell them that. And let's see, I think what I want is this. So you know this one, but I should last two things. What are we working on, and what would we like you to do? Time is of the essence. We're working on Yuri Leskovich and Lisa Kaur from the University. Yuri, of course, from Stanford, both working on graph comparison features. Network motifs as a way of getting a, how is my Tuesday graph different from my Wednesday graph? We have just implemented the first version of our keyword network extractor. So using the tool, you end up with this column of tweets. You can now press another button, and the tweet text is transformed into a network based on is the word text in the. That's a very crude form of co-occurrence. The University of Graz, Marcus Strohmeyer, who has written a worldwide 9 forms of textual co-occurrence in Twitter alone. We're implementing 8 of them. We just decided. And so we're going to actually implement this. You'll get keyword networks in NodeXL very soon. Many people want us to be on the web. We do too. It's just that it isn't, so we won't be. But we do have a vision, way of asking for a graph, getting a graph in a format. I'll use some pictures, and then we'll let you download the Excel file there. And I think I've just talked about federated data. So what could you do for us? Well, if you use the tool, we're delighted. If you have bug reports, we are happy to take them. We'll fix them. The message board at Codeplex, nodexl.codeplex.com is monitored. It rings my phone. And so we will get back to you in less than 24 hours. If that's not fast enough, call me. We really want to make people who use this tool succeed with the tool. So we really need your feedback to make that. We'd love to see you teaching with the tool. Welcome. There is a. All right. So with that, I think you go. That's my story. We have a moment for a question. That's a good idea. I like that. Huh? Yeah. You can do. We have on the message board, if you look for the word API and programmer in the message board, and I'll happily send you the link, we have a DLL It's open code. You take the DLL. It's sort of the sample default. If you were going to connect to this and bring it back to us. So think about the way that the telephone switchboard operator used to work. You'd pull something out of here and plug it in there. You pull something. DLL's open code. It's yours. And ask of you to do so. Once you share it with the rest of the planet, we'd be happy to ship it so that others may use your tool. You can color the edges. You can label the edges. Edges may have transparency, and they also can have thickness. We don't yet do dashed, dotted, that kind of thing. So we don't have the. I'll note that we're NodeXL and not edge. Like, we don't care about edges. But we're starting to care more about edges. But you do get some basics. You get to put a label on it. We'll even automatically truncate your label if you want us to. Color, we'll give it. So if you can tell me what kinds of edge attributes you do want that we don't have, I'd love to have. No, we don't. We have a hack that gets around it. Basically, you make one big thick edge and make it somewhat transparent, and then put a thinner edge under it. And so you can get multiple edges between A and B, but no, and all of our edges are linear, straight-lined edges. So one of the things we would like is Bezier curves for our edges. How to implement it. That would be nice. We'd love to have curvy edges. We'd be much sexier looking. Other questions, ma'am? Yes, but guess what? They changed. Yeah, so big things happened. First of all, Office 2007 had a 1 million row limit. So most people didn't know that. Office 2010, what's its row limit? N, where N is defined by disk and RAM. So if you have enough disk, your spreadsheet can now be a billion row spreadsheet. Why would you do that, though? Well, maybe it's not such a bad idea. There's one other little technical change that happened in Office 2010. That is, for the first time, 64-bit implementation of Excel. There has never, in human history, been a 64-bit implementation of Excel. And I guess you have to be a little geeky to feel that that's a milestone. But that's a milestone because you could now load a PC with 32 gigabytes of RAM. That's a lot of edge. So there's really not a practical limit. Now, also note, there is a sort of graph macho thing going on, right? How big is your graph? Sociologically speaking, it turns out that the universe is granular. And so looking at a lot of research lately, it looks like going over 40,000 nodes stops having really any predictive improvement. That most things are not greater than 40,000 nodes. Now, I know people are, what about the web graph? It's billions. Yes. So be Google, why don't you? But for a lot of research purposes, a graph is fine. And we're not the 100% case or the 80% case. So maybe you can run past our scale limits, no doubt. But maybe a lot of your research